2. Algebra 2.1 partial fraction 2.11. The denominator contains non-repeated linear factors. That is, for an example, 3x plus 7 by x minus 1 and x minus 2 both are linear. Denominator x minus 1 also a linear factor, x minus 2 also a linear factor. We can write this as a by x minus 1 plus b by x minus 2. The value of a and b are to be determined. 2.12. Denominator contains linear factors repeated n times. For example, 9x plus 7 5 by x plus 4 x plus 1 squared. This is linear. X plus 4 is linear, but x plus 1 is repeated 2 times and not n times. Here 2 times only. Then we can write this as a by x plus 4 plus b by x plus 1 plus c by x plus 1 squared. The value of a, b, c are to be determined. 2.13. Denominator contains quadratic factors which cannot be factorized into linear factors. For example, 2x plus 1 by x minus 1 is linear, but x squared plus 1 is quadratic factors which cannot be linear, which cannot be factorized also. Then we can write it as a by x minus 1 plus bx plus c. The quadratic factor means numerator should be right like that, x squared plus 1. The value of a, b and c are to be determined. 2.2 Permutation. First we can recall factorial. N factorial is equal to n into n minus 1 into n minus 2 into dash 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 3 into 2 into 1 is the factorial. Permutation. NPR is equal to n factorial by n minus r factorial. For example, 5p3 is equal to 5 factorial by 5 minus 3, 2 factorial. We can write it simply from 5, 3 numbers, 5 into 4 into 3, then it is 60. Circular permutation of n things taken all at a time. Time is n minus 1 factorial by 2. 2.3 combination. NCR is equal to n factorial by r factorial into n minus r factorial. For an example, 5C3 is equal to 5 factorial by 3 factorial into 2 factorial. We can write it simply as 5 into 4 into 3 by 3 numbers, 1 into 2 into 3. We can simplify it. We get 10 is the 5C3. Then 2.4 mathematical induction. The principle. Step, let Pn be given statement for n is element of capital N. Step 1. P1 is true. We have to prove that. Step 2. Let us assume that the statement is true for n is equal to k. Step 3. Prove that Pk plus 1 is true. This is the third step. Then, therefore, Pn is true for any value of n, element of capital N. 2.5 binomial theorem. We know binomial theorem says x plus a whole power n is equal to nc0 x power n minus 0 n a power 0 plus nc1 x power n minus 1 a power 1 plus dash 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 plus ncr x power n minus r a power r plus dash 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 plus ncn x power n minus n a power n. This is the binomial theorem. Sum of the coefficient coefficient in the expansion of 1 plus x whole power n is equal to 2 power n. Then the general term in the binomial equation is TR plus 1 is equal to NCR x power n minus r a power r. This is the general term. But the middle term case 1, if n is even, then the number of terms n plus 1 is odd. Then there is only one middle term given by t n by 2 plus 1. This is the middle term.